Okay, today we're going to talk about inverse functions. And the idea of an inverse, the inverse of a function is obtained by you switching all x's and y's. In other words, you're reversing back. So think of inverse, if I drove one way to a city, that's one way. Driving back to to home would be the inverse operation. So the same idea with an inverse function. An inverse function does the opposite of what the function does. It takes you back to where you started from. Okay, and now you could obtain it by switching all x's and y's. So the inverse of a function is obtained by switching all x's and y's. And the graph, if you think about that, is a reflection across the line y equals x. And we're going to look at that in a minute. Not all inverses of functions are functions. So when you take an inverse of a function, doesn't mean you end up with another function. And we'll see why not. Okay, let's just take this example. Here's a function, a straight line. And let's say we have a point here, 2, 1, and it starts at the origin. Well, if I wanted the inverse of that function, this point 2, 1 would be switched to 1, 2. So that's my new point 1, 2. And so the graph would look like this here. So the graph would look like this line here, which is a reflection across this y equals x line. Okay, and we would call this, because this is a function, f to the negative 1 of x. Doesn't mean a power, it means the negative 1 there means inverse function. So that would be the inverse of this function. So now let's look at why not all inverses are functions. So let's go to our old friend, the parabola y equals x squared. And here's a function, y equals x squared, or f of x equals x squared. I want to find its inverse. So as we said, the inverse is obtained by switching the x's and y's. So here I have a point 2, 4. If I switch that, I would get 4, 2. 4, 2, which would be here. 0, 0, if I switch that, that would be 0, 0. 1, 1 here would be 1, 1. Negative 1, 1 would switch to 1, negative 1, so 1, negative 1. We go down here. And then negative 2, 4 would switch to negative 2, 4 would switch to 4, negative 2. So 4, negative 2. So let's make a note of that. These points would be 4, 2, 1, 1, 0, 0, 1, negative 1, and 4, negative 2. And so I join up these dots. And so here's my inverse, which we'll call this f of x. So my inverse of f of x. But is it a function? It is an inverse. It's a reflection of this graph across this diagonal line y equals x. So it is the inverse, but is it a function? No. Why not? Because it doesn't pass the vertical line test. In other words, for every input into this inverse, I get 2 outputs. If I put in 4, I get either 2 or negative 2. So it's not a function, my inverse. But nonetheless, it's an inverse. So what determined that this inverse would not be a function? It is an inverse, but not a function. Well, there's a rule called the horizontal line test, or what we call one-to-one functions. If a function is not one-to-one, in other words, here, if I put in an input of 2, I could get 4, and I put an input of negative 2, I get 4. So in my original function, 2 different inputs could give me that same output of 4, which is fine for a function. But it's not one-to-one. In other words, my output of 4 doesn't correspond to one input. So this is not a one-to-one function. And it doesn't pass, this is the easy way of thinking of it, it doesn't pass what we call the horizontal line test. So if a horizontal line intersects my function in more than one place, the function is not what we call one-to-one. And if it's not one-to-one, then the inverse is not a function. So one-to-one means that each output corresponds to a unique input. And in this case, my outputs don't correspond to unique inputs. So it's not one-to-one. But if you want to think about it graphically, one-to-one means that any horizontal line would only hit it in one place at most. And in this case, the horizontal line is hitting it in 2 places. So it's not 1-to-1. So my inverse will not be a function. So let's look at how you find inverses algebraically. We know graphically you switch the x's and y's. You switch to the points and you get the graph of the inverse, which can or may not be a function. On the other hand, if you have algebra for a function, how do you find the inverse of this function? Well, for example, like f of x equals the square root of x plus 1. How do you find the inverse of that algebraically? Well, you switch x's and y's first of all. Remember, f of x is the same as y. So you switch x and y, and then you solve for y. So let's take this example. Here I have f of x equals the square root of x plus 1. So I'll rewrite that as y equals the square root of x plus 1. Now I'm going to switch x and y. So what I have is x equals the square root of y plus 1. So I switch my x and y. Then we solve for y. So how do you solve for y? I want to get rid of this square root, so I should square both sides. And so what I'll have is x squared equals y plus 1, because I square root, gets rid of square root. And then I solve for y. Remember, I'm solving for y, so subtract 1 from both sides to get y equals x squared minus 1. So subtract 1 from both sides. And then this is my inverse function. So f inverse, so I could say f inverse of x is x squared minus 1. So here's my function. F of x equals square root of x plus 1. And here's my inverse. F inverse of x equals x squared minus 1. Now, one thing to know, when you find inverses, the domains and ranges switch, because we're switching x's and y's. So let's do that for this function. What was the domain and range of the square root of x plus 1? Well, the domain of this would be, well, you can't square root negative numbers, so from negative 1 to infinity, because anything below negative 1 would make this negative underneath the root. So negative 1 to infinity. And the range, since we're talking about a positive square root here, it means it's going to be all positive numbers, including 0. So we'll go from 0 to infinity. That's the range of that square root of x plus 1. On the other hand, what is the domain and range of this function, the inverse function, going to be? Well, remember they switch domain and range. So the domain of this function will be from 0 to infinity, because it's coming from this range here. And the range of this new function, this inverse, is going to be from negative 1 to infinity. So the domain and range switch. So now you might be saying, well, this is a quadratic function, x squared minus 1. Its domain should be all reals. Well, that's true if it were just the function we're talking about, but it's coming from, remember, this inverse is a result of this function here. So we have to look at the continuity here. This inverse is the inverse of this function, and by definition, the inverses, the domain and ranges switch. So always look at the problem in context and that domain in context.